Hello class, this is Mr. Hart, and in this podcast we want to start a unit on coordinate geometry. And in this unit we're going to find some specific values dealing with shapes in the coordinate plane, and the first of those is what we call the distance value, or the distance formula. Okay, so you probably have seen this before in a previous math class, but the distance between any 2 points is the distance between the x values squared plus the distance between the y values squared, all square rooted. Okay. And it comes from a rewriting of the Pythagorean theorem, which I showed you in class, but we're not going to take the time to do that right now. But the important thing is we just need to find our 2 points. We find the x value of the second point minus the x value of the first point, and we find the second value of the y value of the second point minus the y value of the first point, and plug it into this formula. Okay. And so let's just try an example problem really quick to make sure we got this down. Okay, so we want to find the distance between the points 4, -3 and -5, -7. So if we can envision this in the coordinate plane, we're trying to find this point 4, -3. Well, that's going to be 1, 2, 3, 4 over, and 3 down, 1, 2, 3, right there. And this point -5, -7 is going to be -1, 2, 3, 4, 5, and 7 down, 1, 2, 3, 4, 5, 6, 7. Okay. And so we're trying to imagine what that straight line distance is between these 2 points right here. Okay. And so that's what we're finding, the distance from that point to that point, or basically how long that line is right there. Okay, so let's switch back to the other screen. So to find the distance between those 2 points, we're just going to use our distance formula. The distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. And so we just have to figure out what is x2 and what is x1, what is y2 and what is y1. Okay, so if we look at the points right here, let's say this is the second point. This is going to be the x value of the second point. That's going to be the y value of the second point. This is going to be the x value of the first point, and this is going to be the y value of the first point. Okay, so we just replace those in the equation, so we get it's equal to the square root of x2, which is -5, minus x1, which is 4 squared, plus y2, which is -7, minus y1, which is -3, or plus a +3. Okay, minus a negative is the same as plusing a positive. Okay, squared. So now all you have to do is just simplify this out. Okay, so that's going to be equal to the square root of, let's see, -5 minus 4 is -9 squared. Okay. -7 plus 3 is going to be -4 squared. Okay. So if we make some more room, that's going to give us the square root of -9 squared, or 81, plus -4 squared, which is 16. Okay. So 81 plus 16, that's going to give us the square root of 97. Okay. So there you go. That's our distance. And just like when we were doing the circles unit, this is what we consider our exact answer. If we need to make an approximate answer, we just type that in our calculator. Okay, square root of 97, and that's going to give us 9.8. Okay, but usually we can just leave it in the exact form unless it asks otherwise. You can just leave it as square root number. Okay, square root 97, whatever it is. Okay, so that means the distance between these 2 points is the square root of 97, or approximately 9.8. Okay. Alrighty, so that's how we find the distance. Let's look at some applications of this. Okay, so when we're using this for the coordinate plane, the distance formula is going to be really helpful for us when we're trying to determine if we have a circle in the coordinate plane, and also if we have an isosceles triangle in the coordinate plane. Okay, let's start with circles. Okay, so if you think back to the circle unit and just think about circles in general, okay, a circle has basically 2 characteristics, okay, a center point and a radius around the outside of that point. Okay, so let's say Z is the center, then it has a radius, okay, around the outside of that. Okay, that's how we determine what a circle is going to look like, the center point and how far out from that point you are. Okay, the radius. So let's say we're in the coordinate plane, we have a couple points, and we're trying to determine if they lie on a circle. Okay? If we have 2 points that are both the same distance d from a center point, then they will both be on the circle around that point with the radius a. So right here we have the center point z, and we're trying to determine if a and b are on the same circle. Well, if they have that same distance d away from that circle, okay, or away from that center point, then they are on the same circle. Okay. So let's look at an example problem. So we're given a circle with a center of -2, 3. Determine whether or not the points -4, -1, and 3, 5 are on the same circle. Okay. So if you kind of think back to that last picture, we're trying to determine if the distances are the same. So we're going to set up 2 distance formulas. Okay. One is going to be for the center compared to this point right here, and the other is going to be for the center compared to this point, or sorry, the center compared to this point right here. Okay. So this guy right here is always going to be x1 and y1, and then in the first distance formula, this is going to be x2 and y2, and in the other one, this is going to be x2 and y2. Okay. So let's just set both of them up. Okay. So x2 minus x1 for this one is going to be -4 minus a -2 or plus a +2. And then y2 is going to be -1 and y1 is going to be 3. Okay, so that's our first formula. Let's set up the other one as well. Okay. So x2 is going to be, x2 is going to be 3 in this case. It's the second point. Minus a -2 or +2. Okay. y2 is going to be a 5, and y1 is going to be a 3. So now we have the distance for each point compared to the center. Okay, and now we just have to simplify these and see if they give us the same formula, okay, or give us the same distance. And so let's see, on this side we got a -4 plus 2, that's going to give us a -2 squared. And then on this one right here, we got a -1 minus 3, which is going to give us a -4 squared. And then let's actually just continue with this one. -2 squared is going to give us 4 squared. -4 squared is going to give us 16. So that's going to give us square root of 4 plus 16, or in other words, square root 20. Okay. So now let's do this one and see if we get the same thing. Okay. So 3 plus 2 is going to give us 5 squared. And 5 minus 3 is going to give us 2 squared. That will give us 25 plus 4, which is not going to be the same thing. That's going to give us square root 29. Okay? So now we see square root 20, square root 29. These 2 points are not the same distance from the center, so they cannot lie on the same circle. Okay? They're different distances. They can't be on the same circle with that center point. Okay? If in the end we did this and we got the same number, then they would be on the same circle. But in this case, they are not. Okay? All right, let's move on to triangles. Okay. So when we're dealing with triangles in the coordinate plane, we're interested in isosceles triangles in particular. If you remember from a previous math course, isosceles triangles are defined as having 2 equal sides. So if you look at this picture right here, this side, A to B, and this side, B to C, are the same length. So they make an isosceles triangle. And so in order to determine if we have an isosceles triangle in the coordinate plane, we're going to look at the 3 points that we have, and if 2 of the distances between those points are the same, okay, then we have an isosceles triangle. Or in other words, if 3 points form an isosceles triangle, then 2 of the distances between the 3 points must be the same. Okay, so we figure out each distance. If at least 2 of those are the same, we have an isosceles triangle. Okay, let's look at an example problem. So given the points 0, 2, 4, -2, and -1, 3, determine whether or not the points form an isosceles triangle. Okay, so with circles, we just had to find 2 distances. With isosceles triangles, we're actually going to have to find 3. Okay, so let's split it up into 3 different distance formulas. Okay, so in the first case, we're going to be doing these 2 points compared to each other. In the next case, we're going to do these 2 points compared to each other. And in the last case, we're going to do these 2 points on the outside compared to each other. Okay, so in the first case, we're going to look at this point compared to that point. So we just plug it into our formula. In this case, x2 is going to be 4. x1 is going to be 0. We square that. y2 is going to be negative 2. And y1 is going to be positive 2. We square that. Okay, let's simplify this out. That's going to give us square root of 4 minus 0 is 4 squared. Negative 2 minus 2 is also going to give us a minus 4 squared. That's going to give us square root of 16 plus 16, which gives us square root of 32. Okay, so let's compare it to the other ones. So now we're going to do these points, okay, this point and that point. Square root of x2 in this case is negative 1. x1 is 4. y2 is negative 3. And y1 is a negative 2 or plus a positive 2 squared, running out of room, sorry. If we simplify that out, we get negative 5 squared plus 1 squared. That's going to give us square root of 25 plus 1, or square root 26. Okay, so now we just have to determine this last one, this last distance, it has to either be equal to 32, square root of 32, or square root of 26, or it is not an isosceles triangle. If it happens to be equal to one of those, then it is an isosceles triangle. We need at least 2 to match. Okay, so let's see. We do square root of, in this case, this will be x1 and this will be x2. So x2 is 0 minus a negative 1 or plus 1 squared. Y2 in this case is 2. And y1 is negative 3 or plus a positive 3 squared. Let's see, 0 plus 1 is going to give us 1 squared. 2 plus 3 is going to give us 5 squared. And we see that we're going to end up with the same thing because we get 1 plus 25, which gives us square root 26. So there we go. This guy right here and that guy right there match. So voila, we got a matching pair of distances. That means that we have an isosceles triangle. So yes, this is an isosceles triangle because at least 2 distances are the same. Okay? Awesome. So that's your homework for tonight, is using the distance formula to determine if you have a circle or if you have an isosceles triangle. Hopefully that makes sense. Let me know if you have any questions, and thank you for watching.